Hi, my name is Matt Lucas and I work in the connectivity and integration team here in IBM Hursley. Welcome to this live Google Hangout, unless you're watching things later on YouTube. This is a live Google Hangout called What Can Integration Do For Me? As ever, you can tweet your feedback using the hashtag IBM Integration, or you can message me directly at MQMatt. That's with 2 T's. So the purpose of today's session is to give you a technical overview of what are the different architectures of integration that are available, what are the different styles of integration that are available to a software developer. So it is very much a technically focused session, so there's going to be no business value assessment of what an ESB is or anything like that in this session. Very much technically developer focused. And also not product specific as well. You could take everything that I'm saying, you can apply it to whatever vendor you happen to be choosing. So I'm going to take you through all the different architectures, different styles, different ways of doing integration, list the pros and cons, and hopefully come to some conclusions at the end. And I'm going to do that through some animations that I have put together. So you should be seeing here 4 different shapes on the screen. Now, developers are being asked more and more to do more and more with limited resources, and so it's more important than ever to be able to reassemble and reuse technology. And systems integration, all that is, it's about making different systems work together in a way that is providing value to the business. And the 4 shapes that you can see here represent 4 different types of application that may exist either in your enterprise or outside of it. So, for example, it could be a messaging system, one could be Salesforce or SAP, one could be a mobile app or a messaging system, or whatever. And they're all going to expose a set of inputs and a set of outputs. They're all going to do something. They're going to provide some value somewhere. They could be local. They could be interacting with each other using things like procedure calls, exposing APIs. They could be remote, so they could be serializing data over the network via the means of a particular message format and protocol. Now, let's say I had a need as a developer to get these different endpoints to work together. How could I technically achieve this? Well, the first approach that might be appropriate could be to take those endpoints and compose them in the form of a monolithic stack. Frameworks exist that allow you to do this and allow you to call between the different endpoints in a very natural way. If your endpoints comprise a similar structure and style, this is a very common way of composing application logic. Now, on the plus side, you're in complete control of everything. You can define the interactions precisely. You're able to do everything using code, and you maintain all of the interactions yourself, including all of the plumbing needed to connect the things together. Now, as a result of this, it is more to maintain, and it's also less suitable for diverse languages and where you have very esoteric, very different data formats and protocols. Let's also look at the reuse model in this particular scenario. Reuse is achieved by adding more things to the same stack. Because everything is in code, you do run the risk of your solution being duplicated, which can lead to problems of code management and control. Another approach is to separate out the endpoint's logic and to manage it out as a separable entity or service. Now, you can still access your endpoints from within a stack, but you can do this using a proxy design pattern or client library. So in this case, the main business logic is separated out, but you have a stub piece of code, a client library or a proxy that is inside the stack. And that proxy may or may not be hosted in the same environment as the business logic. Now, this is good because the business logic is encapsulated in its own place, it's separately managed, and it's still in your control. Now, unfortunately, calls are still from the central stack in this particular scenario, and so it does require you to write and manage your own plumbing code. It also does require close coupling between the proxy and the business logic, and so you will need compatible versions of the proxy client and the business logic. Star integration. So this approach allows you to access your endpoints from anywhere. They don't need to be on a single stack. Endpoints can access other endpoints. So unmanaged environments will naturally navigate to what we call star integration. Now it's called star integration because of connections radiating from each application endpoint. Less favorably, it can be often referred to as spaghetti integration because it quickly can become messy and manageable, particularly the more endpoints you add. In computer science terms, it's an O of n squared problem because the more endpoints you add, the problem does get exponentially worse. There is an approach to managing this complexity by removing the endpoint's abilities to connect to each other in a point-to-point manner, and instead connecting via a single hub. And this is known as horizontal integration. Now, in horizontal integration, you put a single hub or bus that each of the endpoints connects to. Endpoints connect to the bus, and the bus is responsible for routing and transforming data between the endpoints in a way that provides business value. It means that the bus worries about the data routing, the data transformation, and the endpoint focuses purely on the business logic. So as a developer, it's good because it saves you time, saves you things that you need to maintain. So you don't need to worry about the plumbing if you do things in this way. Software systems are becoming ever more sophisticated, and the time we have to develop and maintain such systems is shrinking, which makes it increasingly important to be able to make use of what's already around. This approach also means that you can add new endpoints at minimal cost, so it scales really well. And it also gives you a single point of management. As the bus owns in-flight data, as it passes between the source and target systems, albeit for just a brief period of time, it does give you a natural place to do auditing, workload management, and so on. Now, on the downside, it does take a lot of upfront time to implement. Now, I would caution that a lot of people assume that tomorrow's requirements are going to be pretty much the same as today's. Integration spaghetti does emerge over time. The temptation is to assume that you're only going to ever need to connect a handful of connections and to avoid this upfront cost of managed integration. But then, each new application does compound the problem until sometimes it can be too costly to put right. The other downside is that you are going through an extra hop when you do integration in this way. So you do need to design the system to avoid any single points of failure and to ensure that the data is distributed between the source and the target endpoints efficiently. Now this, in my experience, is usually seen as a pretty reasonable trade-off. This concept has actually been around since the 1990s. There were a set of common patterns for enterprise application integration, and there was a common design for integration called hub and spoke, where endpoint spokes connected into central hubs. Now, what happened around the mid-2000s was the whole wave of SOA came about. And this got people thinking about their endpoints in the form of services. Now, specifically, when we talk about services, we mean the inputs and the outputs and the operations that define all of these different endpoints. So if you think about the integration problem in this way, if you think about your endpoints as services, you're pretty much there in terms of service orientation. And what you can do is you can define them formally as services, and then you can optionally catalog them and create an application inventory, which is often used for control access and governance. Now, when an application invokes a service, it actually invokes a service facade running on that invocation layer that maps to the real backend service, thus shielding the requester from future implementation changes to that service and any internal complexity. Now, the enterprise service bus concept was coined around the same time and really is a core part of this idea. Now, at the same time, web services were in their ascendancy, and a lot of people assume that an ESB required you to use web services. However, that's not really important for the ESB concept. ESB really is just an architectural pattern, and you can closely or loosely tie it to the technology as you need it to be. It remains today a good fundamental best practice for the purposes of integration. The final piece of the puzzle is one that we refer to as gateways. So not all endpoints will want to connect directly to that hub. If you're dealing with external vendors, for example, or the wider internet, you'll want them to go through a single common entry point. Now, often this entry point is going to be inside a demilitarized zone, but that's not necessarily the case. It could be a single logical point of entry into a connected set of systems, all of which happen to be in the back end. They can add security services. They can do things like initial load balancing. It's also a good place to do API management. And they can also provide connectivity to a class of service, such as business partners and the cloud. So as I say, that is the final part of the puzzle. Hopefully that's given you a good feel for the different styles of integration, the different ways that you can do integration there. When choosing an appropriate technology for doing integration, there are a few good software engineering principles that you really should bear in mind. The first one is about value, about maximizing the amount of value by minimizing the number of moving parts in a system. Now, in any system, the more moving parts that you've got in there, the more opportunities there are for failure. So every single component that you add to a system for the purposes of integration needs to add value. That's just a general good rule of thumb. The second one is about coupling. How do you minimize the coupling between all of the different endpoints that you want to connect? If you make the assumption that all your different services that you're adding or different endpoints are going to change, then that will add flexibility to the environment. The introduction of facades will certainly help there, as they shield the requester of information from the consumer of information. The third good engineering practice that you'll want to bear in mind is about how you perceive the cost of implementing that particular solution. Now, if you're just implementing a handful of services, you just want to integrate 2 or 3 things together, then the cost of doing point-to-point integration can be very alluring. But consider what your requirements are going to be 2, 3, 4, 5 years down the line as more and more endpoints come online, as your business requirements change, as you get asked to implement things like audit or common security models or monitoring, how these things then go and add to the cost of doing that integration. But also, it's not just the development cost, it's also the maintenance cost. And quite often, if something's going to be in use for quite a while, then the maintenance cost is going to completely dwarf the upfront cost of developing the solution in the first place. Now, for these reasons, we do find that for more than the simplest of scenarios, then having a horizontal integration approach really does work out best. And from a developer point of view, the reason why it's good is that you can focus purely on writing the business logic. You don't need to focus on things like the plumbing, how the data moves from point A to point B. You can let some other technology take care of that, such as an enterprise service bus. So that's everything that I had to cover today. Hopefully that's been of use to you, and hopefully it's of use for you to find out what the different styles of integration were and the best practices, the pros and cons associated with them. Now, for those of you who've been following along with this podcast series, there are we've done a few of them now. The next one we won't do next week because we do have our IBM Interconnect conference that's going on in Vegas, but we will be back in 2 weeks' time when we'll be joined by Klaus Jensen, one of my colleagues, who will be talking about APIs. So hopefully you can join us then, and see you again soon. Bye-bye.